Hi everyone. So you might be asking yourself, Mr. Dramus, you have this amazing brand new light board. When are we actually going to be able to see it? That's a good question. And I have a couple of reasons for that. Number one, so the 3 videos or 4 videos or whatever videos that I had made earlier on the light board, I don't know where they are. I don't know how to extract them. Just something's just really funky about the whole process. Okay, so that's number one. And number 2, which is more important, him. See, right now, the Mad Titan is chewing on a bone. I had put some peanut butter inside of that bone to make it just a little bit more attractive for him. And once he is finished with that bone, which might be any minute, I can no longer record videos because he's psychotic. So let's just get back to what's going on. You might be saying to yourself, Mr. Dramus, why don't you just have him chew the bone upstairs? Well, because that room still has a lot of boxes in it from the light board, and he loves boxes. So I'm not gonna go that way today. Anyway, let's go to GR01, graphing rational functions. This is gonna be easy and quick because you should already know how to graph a rational function. I'm just going through the motions of kind of giving you some steps again, and then we're gonna do an example together. So here are my steps to graphing a rational function. Step number 1, find the Y-intercept if it exists. You're gonna know very clearly when it doesn't exist or when there's a hole there. Case in point, our first example, you're gonna see what's going on there. Number 2, find the X-intercept or X-intercepts if, again, they exist or it exists. Then we're gonna find the vertical asymptote when we set the denominator equal to 0 and solve. Now, it might have a hole. Now, I wanna specify a little bit of something that I mentioned last week in class. If it's got a hole, it must have a common factor on the numerator and the denominator. So it's always important to go ahead and factor the rational functions numerator and denominator in the event that you have a hole. And again, we'll play with this a little bit just in a minute. Number 4, find the horizontal asymptote. Remember that has the 3 rules. N and M represent the power or the highest exponent of the leading coefficient in the numerator for N and the denominator for M. If N is less than M, the the X-axis is the horizontal asymptote. The second choice is if N equals M, then the line Y equals A over B is the horizontal asymptote, A being the leading coefficient of the numerator and B being the leading coefficient of the denominator. And the final choice is if N is greater than M, there is no horizontal asymptote, but the star here represents that it might have a slant. It won't always have a slant, odds are it will, but that's not a hard and fast rule. Sometimes there isn't a slant nor a horizontal. For it to have a slant asymptote, the power of N must be exactly 1 more than the power of M. And I did not mention that last week. I had forgot that rule. So here we are. Now, slant asymptotes. If there's a slant asymptote, remember there's no horizontal asymptote. And N is exactly 1 more than M. And there's 2 ways we can do this. We can find it by dividing using long division, or we can divide using synthetic. And remember, if we use synthetic or long division, the remainder that's left over once we divide doesn't matter. It kind of goes away. And slant asymptotes are always in the form of a line, y equals mx plus b. Okay, so let's do one example. Here is my example. F of x equals x squared minus 3x divided by 2x squared plus 6x. Okay, so my first step is to find the y-intercept. Remember, the y-intercept is when I plug in 0 for x and solve. Uh-oh, there's a problem here. Because if I plug in 0 for all of these terms, I get 0 over 0. And I don't know about you, but 0 over 0 can't be done. That is not a thing. We cannot divide by 0. Doesn't matter if 0's on the top, we can't do it. So, there is a y-intercept, but there's a hole there. We cannot have a y-intercept that has an actual point there. It has to be a hole. So we'll get back to that. So we're going to put hole. Okay, we'll get back to that in a second. X-intercepts, if there's one or the other. X-intercept is when I plug in 0 for f of x and I solve for x. Remember, this part's actually pretty simple because all I'm doing is I'm multiplying on both sides by the denominator, which will always get rid of it on both sides. So I'm going to have a nice, easy equation to solve. Doesn't matter, that's a quadratic. I'm going to get two values here. I'm going to get x, I'm going to get x minus 3. So 0 and 3 are my x-intercepts, but I can't use 0. Okay, because we know that there's got to be a hole on this point somewhere from the previous y-intercept step. So let's take a look at 3. Okay, so if I plug 3 back into the denominator, right, I'm going to get 9, 18, plus 18 is 36. That's irrelevant is the value that I get. 3 is a valid x-intercept, so I know that 3 is my x-intercept. Okay. Next is, let's find the vertical asymptote. And that's when I set the denominator equal to 0 and I solve. So 2x squared plus 6x equals 0. I'm going to have a 2x come out, and I'll be left with x plus 3 equals 0. Now, again, I have a 0 and I have a negative 3. There's a hole at 0 from the previous step that we did with the y-intercept, so that can't be it. And even if I plug it back in, I get 0, so that doesn't work. Negative 3 is the only value that's going to work for me, and I can plug that back in, and I know I'm going to get something that doesn't work. So negative 3 is my vertical asymptote. Okay. We're good to go here. Horizontal asymptote. Okay. Horizontal asymptote, let's go back to the rule. I've got a 2 and a 2. N is 2, M is 2. They're both the same. Now that they're both the same, I know that the line y equals a over b has to be my horizontal asymptote. Well, a is 1 and b is 2. So my horizontal asymptote is the line y equals 1/2. I know there's a horizontal asymptote, so there is no slant asymptote. So let's go ahead and try to graph this a little bit here. Again, my x-intercept is 3. My vertical asymptote is negative 3. My horizontal asymptote is 1/2. Okay. Now, let's get back to the y-intercept. Then the y-intercept was a hole, okay? And that hole was going to be somewhere on this line. So now it's not going to be 0. It's actually going to be negative 1/2. So how did I get negative 1/2 as my hole for this value? That's a good question. And the answer to that is because once I make a table of values and once I graph this function, I'm going to know that because there has to be a hole somewhere in this area, the x-intercept and the horizontal asymptote prevent this function from going above. I know it's got to cross here at some point. Because it crosses this point somewhere but can't go above this line, my y-intercept has to be somewhere along this point. And it's going to be at negative 1/2. Your table of values, which I'm not going to do for this problem, will help you find out where my hole or my y-intercept approaches. And we're going to finally get a value of negative 1/2 here if I did this, but I'm not. And then if I know that the line goes here, I know that the opposite has to also be true. Voila. Let's go for another one. Example 2. F of x equals negative x squared minus 5x minus 4 over x squared plus 2x minus 8. First step, y-intercept. Y-intercept is when I plug in 0 for all these values. When I do that, I can't say, I'm going to get negative 4 over negative 8, which is 1/2. So my y-intercept, and we can do this right here easy, is going to be 1/2. Now, let's find the x-intercept. X-intercepts when I plug this in for 0 and I solve, but when I multiply by the denominator on both sides, I'm going to get the function or the value x squared minus 5x minus 4. I'm just going to take a negative 1 out by factoring to make it easier. X squared plus 5x plus 4. Okay, because the negative 1 is going to go away. I'm going to factor using inspection. I know I need an x and an x. I know I need a 4 and a 1. And since they're both plus signs, they're both plus signs here. So now my values are negative 4 and negative 1. So they probably can't both work. So let's figure out what's going on here. If I plug in negative 1 to the denominator, I'm going to get 1 minus 3 minus 8, which is negative 2 minus 8, which is negative 10. That's a value. okay? And that value is irrelevant, but because it actually works, -1 is an X-intercept. Let's plug in -4 and see what happens. 16 minus 8 minus 8, which is 0. That can't work. There's a hole there at -4. Okay, so I know that that has to work. Now, I know it's a hole there, okay? Because there's a common factor going on here. Well, let's go ahead and do that. So I know that I'm going to have the -1 come out. I've got an x plus 4 and an x plus 1. Now, the denominator is also going to give me something like that. I'm going to have an x plus 4 and an x minus 2. Because there's a common factor of x plus 4 here, that proves that there's a hole at -4. Okay? So this is something new that we didn't talk about last week. So my x-intercept is -1. Okay? And there's a hole at -4. Now, I don't know exactly where that hole is. It can't be an x-intercept because it's just not the way that works. So I'm just going to put it a little bit below there because this looks like it's going to work like this a little bit. Vertical asymptote. Set the denominator equal to 0 and solve. Well, I kind of already did that over here, right? So let's just do that again. The denominator is x squared plus 2x minus 8. Factoring out x and x, I know I need a positive 4 and I know I need a -2. But remember what we talked about, the common factor here. That doesn't work. There's the hole there. So x equals 2 is my vertical asymptote. So this is 1, this is 2. Okay. Horizontal asymptote. You see that? I don't think you can see that. Okay. Horizontal asymptote, let's take a look at the function again. And the function's got a 2 and a 2. That means I'm going to use the line y equals a over b. And the line y equals a over b is going to be -1 over 1. So the horizontal asymptote is y equals -1. So this might be a -1 here. Let's make this happen like this. Okay. So now I've got all my values. I know there's no slant asymptote. I know I've got everything else I need. So the hole is going to be exactly kind of where we said it was going to be. It's going to be about right there. This function is going to go up like so, never touching the line y equals -1. And then the catty corner, the other corner of that is also going to be part of the function. So this is the function, very crude-like function, -x squared minus 5x minus 4 divided by x squared plus 2x minus 8. Long video, sorry. Bye.